Hey guys, so in this video we're going to be talking about simple harmonic motion, also known as SHM. Specifically for this video we're going to be talking and focusing on springs. Alright, so let's review really quickly. So for a spring we know that force is equals to negative kx, right? And that's the case where a spring is right here, right? And you have it attached to a wall, right? And this is your x naught. However, I also want to let you guys know or express the fact that the force can also be equals to kx. And this situation specifically, when it's negative kx, is for the case where you are pushing into the spring. So you're pushing into the spring and you will compress it and it will end up being here. And this is your distance travel, which that would end up being x, so your new spring would be compressed right here. That's where it's equal to negative kx. And in this other circumstance, for when it's equals to kx, it's when you have your regular case, but instead of pushing into the spring, you are pulling out. So the force is being exerted outward, and here is being exerted inward. And then, of course, your kx would be somewhere. Your new x would be somewhere outward. So, all right, now that we got that out of the way, let's define some terms that are very common when it comes to springs. So first you have the amplitude, so denoted by A, which is equals to amplitude. And that's just equals to x. Or the way you can think about that is how much the spring stretches. So the stretch of the spring. So from here to here, that's x, but that is also known as A. And then from here to here, it would also be known as A. Of course, again, because we're pushing into the spring, this would be negative A, negative x, and then this would be positive A, and this would be positive x. Right? So the amplitude is just equal to the stretch. Now let's talk about period. The period is just denoted by T, and what that really means is just a measure of total time that it took the system to complete one cycle. So time per cycle. The way you can think about this is kind of like how much time it took you to complete a task. So for example, if you're eating a candy and it takes you 25 seconds to eat a candy, your period would be 25 seconds per candy, right? Or just 25 seconds because you would know that the candy is what you're eating. Now let's talk about frequency. That's another term very important in this kind of physics. So the frequency is just a way of measuring how fast something is going. So it's just the inverse of period. So it's cycles over time. And then, for example, if we use the candy again, in this case, if we do the inverse, we would find out that is 0.04 seconds, part of the candy per second. So if you haven't noticed, I'm pretty sure you have noticed already, but the inverse just means T, or the period, is equals to 1 over frequency. So this relationship is very critical, and this is how you get 25 seconds per candy, and then you can translate that into the frequency as 0.04 candy per second. It's just frequency is kind of the speed, how fast something is going. So yeah, now that I hope that makes a little bit more sense now. And now if you want to think about this as well, it's just you're eating 4% of the candy, right, every second that passes by. All right, so that's just clarifying some terminology that we're going to be using in the future for future videos. In the next video, we're going to be talking about how formulas that are given, such as x equals, that's not a very good color, I apologize, let me choose this one. Alright, so how the formulas x equals 0.2 meters cosine 8t can be used to find the amplitude, the angular velocity, the period, and the frequency as well, just by looking at this formula. So I hope you guys tune in next time, and remember, comment on the videos, let me know what I can do better, what you guys want explained, and remember to like us on our social media. I hope this was helpful. Good luck with your study.